Today's our lecture is fuzzy expert system and fuzzy inference. We already study the fuzzy expert system, and we already know about the what is expert system. And today we are study that is the Mamdani fuzzy inference system. And the most commonly used fuzzy inference technique is the so-called Mamdani method, and that is uh, built in 1975 by the professor Abraham Mamdani of London University, that built the first fuzzy system to control a steam engine and boiler combinations. He applied a set of fuzzy rules supplied by experienced human operators. The Mamdani fuzzy inference process is performed in four steps. The first is fuzzification of the input variables. Second, rule evaluations. Third, aggregations of the rule output. And finally, defuzzification. We examine a simple two input, one output problem that include three rules. If x is a3 or y is b1, then z is c1. Rule 1: if the project funding is adequate or project staffing is small, then risk is low. In rule 2, if x is a2 and y is b2, then z is c2. Rule 2: if project funding is marginal and project staffing is large, then risk is normal. And in rule 3, if x is a1, then z is c3. Rule 3: if project funding is inadequate, then risk is high. Step 1, that is the fudgification. The first step is to take the crisp input x1 and y1, project funding and project staffing, and determine the degree to which these inputs belong to each of the appropriate fuzzy set. In the crisp input x1, that is here, we are given the member function that is 0 to 1, and the value of x, that is x1 to x. And here we find the a1, a2 and a3. Here the member function, that is x equal to a1, that is equal to 0.5, and member function x equal to a2, that is the member function that is equal to 0.2. And in the second case, here that is the b1 and b2, here the member function y, that is equal to b1, that is equal to 0.1, and member function y, that is equal to b2, that is equal to 0.7. In the second step, the rule evaluation, the second step is to take the fudgified input, that is the mu x equal to a1, that is 0.5, and mu x equal to a2 equal to 0.2, mu y equal to b1 equal to 0.1, and mu y equal to b2 equal to 0.7, and apply them to the antecedent of the fuzzy rule. If the given fuzzy rule has multiple antecedent, the fuzzy operator and or is used to obtain a single number that represent the rules of the antecedent evaluations. This number, the truth value, is given, then applied to the consequent membership functions. To evaluate the disjunctions of the rule antecedent, we use the OR fuzzy operator. Typically, fuzzy expert system make use of the classical fuzzy operator union, that is the mu a union bx, that is equal to the maximum mu ax mu bx. Similarly, in order to evaluate the conjunction of the rule antecedent, we applied the AND fuzzy operator intersections, and that is the Mamdani style rule evaluations. Here, rule 1: if x is a3, the member function 0 0, or if y is equal to v1, that is equal, it is 0.1, then z is c1, that is 0.1, because here we are using the using the Mamdani style rule evaluation, same as in the rule 2. If x is a2 0.2, then y is b2 0.7, then z is c2 0.2. If x is a1 0.5, then z is c3 0.5. Now, the result of antecedent evaluation can be applied to the member function of the consequent, and the most common method of uh, correlating the rule consequent with the truth value of the rule antecedent is to cut the consequent membership function at the level of the antecedent truth. This method is called clipping, and since the top of the membership function is sliced, the clipped fuzzy set loses some information. However, the clipping is still often preferred because it involves less complex and faster mathematics and generate an aggregated output surface that is easier to defuzzify. While clipping is frequently used method, scaling offers a better approach for preserving the original shape of the fuzzy set. The original membership function of the rule consequent is adjusted by multiplying all its membership degree by truth value of the rule antecedent, and this method, which is generally losses less information, can be very useful in fuzzy expert system. That is the clipped and scaled membership function. Here is the one, here is the degree of membership, that is the membership function 0 to 1, and that is the value of z, and here is value for that, and here we are define the degree of membership function using clipped and scaled membership function. In the step third, the aggregation of the rule output. Aggregation, basically it is a process of unifications of the output of the value. We take the membership function of the rule consequent previously clipped or scaled and combine them into the single fuzzy set. The input of the aggregation process is the list of the clipped or scaled consequent membership function, and the output is one fuzzy set for each output variable. That is the aggregation of the rule uh, output. Here is the aggregation of the output that we are finally get the submissions. Here the fourth step, that is the defuzzification. It is the last step in the fuzzy inference process, that is the defuzzification, and the fuzziness help us to evaluate the rule, but the final output of fuzzy system has to be a crisp number, and the input of defuzzification process is aggregated output fuzzy set, and the output is a single number. The several defuzzification method, but probably the most popular one is the centroid technique, and it is used to find the point where the vertical line would slice the aggregate set into two equal masses. Mathematically, this center of gravity can be expressed as this. Here, the centroid defuzzification method finds a point representing the center of the gravity of the fuzzy set A on the internal AB. A reasonable estimate can be obtained by calculating it over a sample of point. The center of gravity that we are calculating use and value that we are getting the degree of membership function, and how we calculate and how we find the average of that. That is the concept of this. Here we can take the example of the Mamdani fuzzy model, where we have the two input and single output Mamdani fuzzy model, fuzzy models with the four rules. If x is small and y is small, then that is negative large, and if x is small and y is large, then z is negative small, and if x is large and y is small, then z is positive small, and if x is large and y is large, then z is positive large, and x, that is the value here, that is with the max mean composition and centroid differentiation, we can determine the overall input output. surface, and here is the two single input and single output antecedent and consequent membership functions. And that is the graph here that is plotted with the help of the MATLAB. That is the overall input output surface. And here that is the building a fuzzy expert system. That is a case study. A service center keeps spare part and the repair failed once. A customer bring a failed item and receives a spare of the same type. Failed part are repaired, placed on the shelf, and thus become spare. The objective here is to advise a manager of the service center on a certain decision policy to keep the customer satisfied. The process of developing a fuzzy expert system: specify the problem and define linguistic variables, determine the fuzzy set, uh, elicit the and construct the fuzzy rule, encode the fuzzy set, fuzzy rules, procedure to perform the fuzzy inference into the expert system, evaluate and tune the system. In the step 1, specify the problem and define linguistic variable. There are the four main linguistic variables: average waiting time, mean delay, repair utilization factor of the service center. This is the ratio of the customer arrival date to the customer departure rate, and the number of service, and initial number of the spare part. And that is the linguistic variable and their range. That linguistic variable, that is the very short, the numerical range, that is normalized 0 to 0.3, short, that is 0.1 to 0.5, medium, that is 0.4 to 0.7. In the linguistic variable, that is the number of servers, that is the small, medium and large, and that is a range, that is 0.035, 0.30 to 0.70, 0.60 to the point this. And next is that is the linguistic variable of the repair utilization factor, that is the low, medium, high, and that is the range. And next one, that is the number of spares, the linguistic variable, that is a very small, small, or rather small, medium, rather large, large, and very large, and that is the range of that linguistic variable. And the step 2, here we determine the fuzzy set. Fuzzy set can have the variety of the shapes. However, a triangle or a trapezoid can often provide an adequate representation of the expert knowledge, and at the same time significantly simple the process of computations. That is the fuzzy set mean delay, that is the member degree of membership, and here is the mean delay normalization. And here we are find with the use the membership function, that is the triangle membership function. Here we are calculate the membership function using the triangle membership function. Here we are using the very short and medium, and here we are using backward and forward method. The fuzzy set of the number of servers, that is the fuzzy set of the repair utilization factor. Here is the fuzzy set of the number of spares. And step 3, here with the elicit and construct the fuzzy set. Here we might ask the expert to describe how the problem can be solved using the fuzzy linguistic variable defined previously. And it required the knowledge also can be collected from other sources such as book, computer database, flow diagram, and observed human behavior. The matrix form of representing a fuzzy rule is called a fuzzy associated memory, and that is the square representation of fuzzy associated memory. Here we are defined, and that is the server, and that is the mean. It's a large, medium, and small, and very large, very small, small, and medium. And here the representation, that is the medium, small, very small, rather large, rather small, small, very large, large, and medium, that we are already defined the variables in the step first. That is the rule table. Here we are the rule tables, that is we have used the 27 rules for we are designed the rule table according to that. And after that, that is the rule base, and that is the rule base one. If utilization factor is large, then the number of sphere is small, and we are making the such rule. And after that, we are making the cube fuzzy associated memory cubes for the rule base 2. And after that, the step 4, we are encode the fuzzy set and fuzzy rule and produce to perform a fuzzy inference into the expert system. And to accomplish this task, we may choose one of the two options to build our system using the programming language such as C, C++, or Pascal, or to apply the fuzzy logic development tools such as the MATLAB fuzzy logic toolbox, fuzzy clips, or a fuzzy knowledge builder. And in the step 5, we are evaluate and tune the system. That is the last and most laborious task is to evaluate and tune the system. And we want to see whether our fuzzy system meet the requirements specified at the beginning. Several tests situation depend on the mean delay, number of server, and repair utilization factor. The fuzzy logic toolbox can generate a surface to help us analyze the system performance. There is the three-dimensional plot for the rule-based one. Here the three-dimensional plot for the rule-based one. Here the three-dimensional plot for rule-based 2. Here is the three-dimensional plot for rule-based 2. And however, even though the expert might not be satisfied with the system performance, that to improve the system performance, we may use the set rather small or rather large on the universe of discourse, the number of server, and then extend the rule base, and that is the modified fuzzy set of the number of server that we have again modified that it that is the cube fuzzy associated memory rule base 3. That is the three-dimensional plot for the rule base 3. That is the three-dimensional plot for the rule base 3. And that is a tuning fuzzy system, that is the review model input and the output variable. If required, to define their range, review the fuzzy set, and if required, define additional set on the inverse of the discourse. The use of the wide fuzzy set may cause the fuzzy system to perform roughly, provide a sufficient overlap between the neighboring set. It is suggested that the triangle to triangle and trapezoid to triangle fuzzy set should overlap between 20% to 50% of their ways. Review the existing rule, and if required, add new rules to the rule base. Examine the rule base for the opportunities to write hedge rules to capture the uh, pathological behavior of the system. Adjust the rule execution weight. Most fuzzy logic tool allow control of the importance of rule by changing a weight multiplier. Revise shape of the fuzzy set. In most cases, the fuzzy system are highly tolerant of a shape approximations. Here we take the example, and we will try to sort out that example using the fuzzy system here. That is, we have a design controller to determine the wash time of the domestic washing machine. Assume the input is dirt and grease on the clothes, and use three variable and five descriptor for output variable. Drive the set of rule for controller action and defuzzification. The design should be supported by a figure where the possible, so that if the clothes are solid to a large degree, the wash time will be more, and vice versa. What we do and how we solve that particular problem, and how we design a controller. Basically, we have to design a automatic washing machine, and that washing machine that manages the time for cleaning automatically. And we have the cloth that is the that may be dirty, or that may be applied a few of the grease on them, and we have to clean that clothes, and we have to manage that. The washing machine has to manage the time automatically. And for that, we have given that here, that you have the two input. One is the dirt cloth, and one and grease. It may be the dirt is small, it may be the dirt is medium, it may be dirt is large. And same as it may be the grease is applied, it may be the grease is small applied, it may be the grease is no applied. And here we have the five output descriptor variable that we can imagine according to us, and according to me, that is depend upon the my imagination, how we create the output variables, five output variables. And here is the one thing is that if the clothes are solid to large degree, the wash time will be more, and the vice versa. It means that if the clothes are more dirty, that the wash time maybe increase, and if the clothes are less dirty, that the degree that is the time of wash maybe minimum, that it will be the vice versa. That how we create that these all things, we will look through that, we will solve that particular program on the paper, and after that we will know how we do it. Let's see that we have to design a controller, mean we have to design a automatic washing machine that manage wash time automatically. According to the fuzzy system, Mamdani fuzzy system, Mamdani fuzzy system, the first step that we have to follow, that the first step is, that is step one, that is the first identify the identify the input and output, identify the input and output variables, and decide decide descriptor descriptor for the same. In step 2, define membership function for each input and output variables. Step 3, from rule base. Step 4, rule evaluation. Step 5, defuzzifications. These are the 5 steps that we use in the case of the in case of that particular problem that we have designed. In the step 1, we have to identify the input variables. In the step 1, we have to identify the input variables. To so the first, that identify the input variable, our input variable is, as we study, that is that the particular problem, that we have assumed the input, that is the dirt and grease on the cloth. The first input variable is dirt, and the second input variable is grease, and we will assume that they are in percentage, that how much percentage it is dirt and how much percentage the grease, we have assumed in the percentage. The second in the step 1, the second phase, how to identify the output variables, to identify the output variable, that the output variable, that is the wash time, that is measured in the minutes. Now the step first, we have identified the first phase, that is to identify the input and output variable. Now we have to decide the descriptor for the same. For the descriptor, we have to find out the descriptor for the input variable. We have to find the descriptor for input variables. The first input variable is dot. So we have to find the descriptor variable, and that is we have in our problem, you have to use three variables and five descriptor, three input variables, uh, three variables for the input, and five descriptor for the output variables. We have used the three descriptor here for the input variable, so we are using the SD, that means the small dot, MD, that mean is the medium dot, and LD, that mean is the last dot. These are the three descriptor, and we have to write these descriptor, that is SD, that is the MD, and that is the LD. That is the descriptor for the this one. Now in the same thing, we have to use for the descriptor for the second input, that is the grease. We have used the same descriptor for the grease here, that is the NG, that is the no grease. That is the MG, that is the medium grease. LG, that is the large grease, and we have to write that NG comma NG comma LG. Here we here we define the three descriptor for the both input variable dot and grease. Now we have to define the descriptor for the, we have to define the descriptor for output variables, and we have the output variable, that is the was time. And so here we are give the variable, that is the very small, small, medium, large, or very large. It depend upon you how you define the descriptor, and that descriptor is defined according to your imagination. It may be 5, it may be 7, it may be 8, it may be a 9, it may be a 10. It depend upon the problem, and it depend upon the imagination, and you can define the number of descriptor according to you. If we have defined the number of descriptor to 7, that we can use that very very small and very very large, it goes to the 7. If we define the descriptor 9, then we are using the very very small, very small, small, rather small, medium, large, very large, rather large. And so it depend upon the your imagination, then how much you imagine. It depend upon you, that how much you imagine. It depend on you, that we have defined, that is VS, that is the very small, that is the small, that is the medium, that is the large, that is the very large. Now the step 1 is complete. Now we are move forward to the step 2. In the step 2, you have to define the membership functions for the each input and output variables. In that particular function, we use the triangular membership function, we use the triangular membership functions, and the first the membership function for the that is mfs, that is the membership functions, that is the ms membership function for dot. Here how we calculate the membership function for the dot, we have the three variables. You have to simple use like this, that is the dot in percentage, and here that is the membership function x 0 to 1. Here we are simple using like this. Here we are using the 50% and 100%. Here using the 50% and 100%. Now we are using the lines like that. Here is the 50 and here is the 100, same as this one, same as this one, same as this one. Here that is the small dot, here that is the medium dot, here that is the large dot. Here we are calculate the membership function as it is. And the membership function, how we calculate the membership function here, that the membership function will be calculate through the forward minus backward divided by the forward minus backward. That is, we are start from here, that is the forward minus backward and forward, forward minus backward and backward minus forward. Here first we have calculate, that is the member function, that is for the small dot, that is x, that is equal to forward minus backward, that is the value x, 50 minus x, and next is the forward minus backward, again forward minus backward, that is 50 minus 0, that is the 50, that is 50 minus 0, that is equal to, जो ये रेंज हमारे पास आ जाएगी, that is 0 to 50 हमारे पास रेंज आ जाएगी. Same as the concept for the medium dot. In case of the medium dot, there is we are getting the two value, because one value is going to this and second value is going to this, and one value is going to this and second value is going to this. So here we getting the two values here, that the first is the forward and backward, that is this 0, and that is x 0, here x minus 0 divided by, that is the this one 50 minus 0, here the range, that is x, that is 50. The second value here we are calculating here, in the second case, that is the this one 100, this one forward backward, that is 100 minus x divided by 100 minus 50. Okay, that is 100 minus x, and that is 100 minus 50, that is equal to 100 divided by 50. So the range is 50 x 100. In case of the membership function large dot, that is only one membership function, that is the x, that is the x here, that is the membership function x minus 50, x minus 50, that is the x minus 50 divided by, that is the this one, that is the 100 minus 50, that is equal to x minus 50 divided by 50. So here 50, that range is x to 100. That is the concept of the membership function for the dirt. And same, we are using the the membership function of Greece. Here we are find the membership function of Greece. परसेंटेज में है ये, ठीक है, that is 0. We are taking here the y, this one, here is the 50 and here is the 100. One value is this, one value is this. That start, that is the no grease, medium grease and large grease. Here that is the no grease, medium grease, large grease. Here we are find the membership function. Here we are using the same concept for the find the membership function, that is the no grease y, that have the only one range, that is 50 minus y divided by the 50. The range is 0 y, that is the 50. Membership function for the medium grease y, that is it have the again two range. The first range, that is y minus 0 divided by 50 minus 0, that is the 0 y, that is the 50. And second range is, that is the 100 minus y divided by the 100 minus 50, that is equal to 100 divided by 50, 100 minus y divided by 50, that the range is 50 to 100. In case of membership function of large grease, that we have to calculate the membership function y minus 50, that is the 100 minus 50, that is equal to y minus 50 divided by 50. The range is 50 less than y 100, that is the range that we are calculate the member function for the grease. Now we have to calculate the membership functions for output variable, that is the was time. Here the membership function, there are the 5 membership function. Here we have to calculate the 5 membership function like this. That one, that we give the chat 0, okay. Here we are define 10, 25, 40, 60. It depend upon you, that you has to define, that is it depend upon your use. You can define 10, 20, 30, 40, 50. You can define 10, 25, 45, 60. It depend upon the you and it is not it does not have any effect on the answers, because you have to complete your own phase. It is the fuzzy system, and you have to it include your imagination, and the every person have your his or her own imagination. So you can use that concept according to you. That is not worry about that, that use the 10, someone use 10, 20, 30, 40, or you use 10, 25, 40, 60. It does not worry about that. Here we are used for the variables, that is the first very small, medium, large and very large. And we start it like this one, 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 like this one. That is the triangular membership function we are using here. Here that is here, that is the chat, that is the was time. that is in minutes. We are using the burst time in minute. Here we are again calculate the member function, that is a very small, that is z, that is equal to, that is here, that is first is the forward, then backward. First is the forward, then backward. That is the first is the forward, then backward. That is the 10 minus z divided by 10. It is going to the 10 minus 10, that is divided by 10. And here we have calculate the value of that particular function, that is the range 0, that is less than then z less than 10. Now we have to find the membership function for the small, that is this one going to the this, and we have to get this two membership function value here. The first, that is the first that is the z divided by 10, that is the range 0 to z, 0 to z 10 range. And second, that is the forward, that is the 25 minus z divided by 10 minus 25, that is the 25 minus z divided by 15. So the range is 10 to 25, that the range is 10 to 25. Here the range is 10 to 25 is range, that is the z minus 0. Here the z, that is the forward and backward z minus 0, and here that is the z minus 0. Now we have to same calculate the member function for the medium, then large, and then very large. We have to now write the membership function for the medium, that is again it again get the two membership function here, because that is for the forward, that is for the forward z, that is for the forward z minus 10, z minus 10, and backward, that is the 40 minus 25, that is 40 minus 25, that is z minus 10, that is 40 minus 25, that is the 5 and 2, 25. So the range is 10 to 25. So the range is 10 to 25. In the second case, that is the 40 minus z, and that is the 15. So the range is 25 to 40. The range is 25 to 40. In the case of large, the membership function, it again gets the 2, that is z minus 25 divided by 15, that is the range is 25 to 40. And the second is, that is 60 minus z divided by 20, because 60 minus 40, that is the 20, that is the range is 40, this one z, this one 60, that is the range. Here we have to calculate the membership function of very large. Here we are calculate the membership function of very large, that is z minus 40, that is the z minus 40 divided by 40 minus 60, that is a 20, that is the range is 40 to 60. Now we go for the step third, that is the step third, but that is the form from rule base. Now we have to in the step third, from the rule base, we have to design this one rule base, that we have the rule base, that one, that one. First is the x and y, that is for the dirt, and that is for the grease, that is for the dirt, and that is for the grease. Here the x and y, and that is the variable, that is the small dirt, medium dirt, large dirt. Here is no grease, medium grease, and large grease. And you can imagine, according to the variable, if there is a small dirt and no grease, that it take very small time to wash. If small dirt and medium grease, then it take medium time. If small dirt and large dirt, then it take large time. If medium dirt no grease, that again it takes small time. It medium dirt and medium grease, it take medium time. Medium dirt large grease, it take large time. Large dirt no grease, it take medium time. Large dirt medium grease, it take large time. Large dirt medium grease, large grease, it take very large time. These are the wash time. These are the wash time. And these are the wash time that is depend upon your imagination, and it might be different for the person to person. uh, I can change this number, change this time, medium time, to the last time. If I think that the medium dirt and medium grease take large time, or I can think that the medium grease and large grease take very large time. It depend upon the my imaginations. That is the concept of the fudgifications, and that is the imagination. That is the no hard fast rule that you have to write the same thing. It depend upon the you, that how you write and how you imagine, and it may be different from the person to person, because it is that is the imagination, that is the only your imagination, that how we set the rule. Now we are move for the step 4. In the step 4, that is what we do, that is the rule evaluation. The step 4, that is the rule evaluation. In case of the rule evaluation, that is based on the approximation and the assumptions. That is based on the approximations and the assumption. That first you have to assume the dirt, that is 60%, and assume grease, that is the 70%. That is the approximation and assumption. That is the approximations or assumptions. That is the approximations or assumptions. Now we have the dirt, that is the 60%, maps to membership functions of dirt. We have to map the two membership function of dirt, because why we map the two membership function of the dirt, because that is the 60%. If we check the membership function of the dirt, that is the 60%, that come in the range of that 50 to 100 and 50 to 100 in the medium dirt range and large dirt range. When we are select the dirt is the 60%, that come in the 2 range. And when we take the grease is 70%, that it again come in the 2 range, that is 50 to 100% in the medium grease, and 50 to the 100% range in the large grease. So we have to map, we have the dirt is 60%, map to membership function of dirt. The first membership function that is the we have, that is the 100 minus x divided by the 50, and the second, that is the large dirt, that is the x, that is the x minus 50 divided by 50 here. And same we have to map the membership function for the grease. Grease is 70%, so there are again two membership functions for grease. The first membership function for the grease, that the membership mu medium grease y, that is equal to 100 minus y divided by 50, and second, that is the large grease y, that is the y minus 50 divided by 50. Now we have to evaluate, that is the mu mdx and mu large dot x for x that is equal to 60. Now we get mu mdx that is equal to 100 minus 60 divided by 50, that is equal to 4.5. That is the first equation. That is the last dot x that is equal to last dot x that is equal to 60 minus 50 divided by 50, that is equal to 10 by 50, that is equal to 1 by 5. That is the second equation. And same for to evaluate the mgy and mu lgy for y equal to 70. We get here we get the value of that particular thing, that mu mg y that is equal to 100 minus 70 divided by 50, that is equal to 30 divided by 50, that is equal to 3.5. That is equation number third. Mu large grease y that is equal to 70 minus 50 divided by 50, that is equal to 20 by 50, that is equal to 2 by 5. That is the 2 by 5. That is the equation number 4. Here these above 4 equations, these 4 equations leads to 4 rules. These leads to 4 rules that we need to evaluate. The first rule that we need to evaluate, that is the first one, that dirt is medium and grease is medium. The second rule, dirt is medium and grease is large. Third one, dirt is large and grease is medium. Fourth one, dirt is large and grease is large. These are the 4 rules that come from the cross multiplication of these value that we evaluate on the member functions, that we are calculate these value. Now since the antecedent part of each of the rules, each of the rule is connected by and operator, we use minimum operator to evaluate strength of each rule. So here we are find the strength of rule 1, that is the dirt is medium and grease is medium. That first rule, that the dirt is medium and grease is medium. Here that S1, that is equal to minimum of minimum dirt 60 and minimum grease 70. The value is this minimum, this value is 4.5, that value is 4.5, and that value is 3.5. Here 3.5, or which value is medium between them, that is the 3.5. The answer is 3.5. Same, we have to find the strength of rule 2, that is the dirt medium grease large. That rule, that is the dirt medium grease large. In that case, that is the S2, that is the minimum of mu minimum dirt 60 mu large grease, that is the 70%. The value of this one is 4.5, that we are already used, and the value of large grease is 2.5. Here's 2.5, and the minimum value between that is the 2.5. Now we have calculated the strength of rule 3, that is the dirt is large, grease is medium. Here dirt is large, grease is medium. This one, that is the S3. We are calculating the minimum value of this mu, that is the large dirt 60 member function. This one, that is the mg 70. Here the value, that is the value, that is the here large dirt, that is 1.5, and second value mg, that is the minimum grease, that is the 3 by 5, and the minimum value is 1.5. Now we have calculated the strength of rule 4, that is the dirt is large, grease is large. Here that is the dirt is large, grease is large. Here the rule number 4, we have calculated the value of that particular rule number 4, that is S4, that is equal to minimum mu, that is the LD large dirt 60, and that is large grease 70. The minimum value, that is the 1.5 and 2.5. Here the minimum value is 1.5. Now we have to again the plot use that particular system, particular table for defining that one, this one, this one, this one, here this one, this one, same for this one. Let us not worry about more. That is for the dirt grease, dirt grease. ठीक है. अब we have to use here, that is the minimum grease, large grease, minimum dirt, large dirt. to rest of this column we have to use this column blank. We have to use this column blank. In same cases here again same cheese, no grease, minimum grease, large grease, small dirt, minimum dirt, large dirt. This one, the value is 3.5, the value is 2.5. Put the values in same place. The value is 1.5, value is 1.5, and here that is the minimum time, here is the last time, here is the last time, here is the very last time. Now we have to calculate, find the maximum member function. The maximum member function is this, and here the value is transformed, that is the minimum, that is the maximum member function shape, and that is a membership function, that is a membership function, that is the maximum membership function we have to find here. Now that is the step 5, that is the defuzzifications, that is the defuzzification. Since we use mean of max, we use mean of max in the defuzzification technique. We are find the maximum, find the maximum strength, that is the max, that is equal to S1, S2, S3 and S4. That is the max is equal to this one, 3.5, 2.5, 1.5 and again 1.5. The maximum is equal to 3.5, and this corresponding to the 3.5, this 3.5 this corresponding to the rule 1. ठीक है, corresponding to rule 1, that is the dirt medium, grease medium, that corresponding to the rule 1. Now that we have to find, now we have to find the final defuzzification value. Now we have to find the final defuzzification value, and we know to calculate that value, to calculate the value we now take average, mean of that membership functions z, that the membership function that z we are use, we have calculated that membership function z, m minimum minimum time, that is the m, that is the m, that is the minimum time, that is the medium time. Very small time we have the 5.5 descriptor, that is a very small, medium, large and very large. Here the maximum membership function is the medium time, so that the membership function of medium time, we have to calculate the membership function of medium time, that is m z, that is the z minus 10 divided by 15, and the second one is the 40 minus z, that is the 15, that we have to get the value from here, the membership function of that here, that is the this one, and second is the 40 minus 15, that is the this one, that we are calculate the value of here. Okay, we will calculate the value of this one from this here, 40 minus 25, that is the 15. I have write that value here, that is the membership function, that is the 15. Now we have apply the value, the maximum value, that is the value of this one is 3 by 5, that is the z minus 10 by the 15, and that is the 3 by 5, that is the 40 minus z by the 15, that is the cross multiplication here, that is the 5z minus 50, that is equal to 45, that is the 5z equal to 45 plus 50, that is z equal to 95 divided by 5, that is z equal to 19. In the same case, that is the cross multiplication, that is the 200 minus 5z, that is the 45 minus 5z, that is the 45 minus 200, that is the 5z, that is equal to 155, that is z equal to 155 divided by the 5, that is z equal to the 31. Here is the 31. Now we have find the average of these one, that is the z star, that is equal to 19 plus 31 divided by 2, that is 50 divided by 2, that is equal to 25. That is 25 is the 25-minute pause time required. That is whole about the that particular problem, that we have to design a controller to determine the work pause time of a domestic wash machine, and that have assumed the input is the dirt and grease, and these are the input are the three variables and the 5 descriptor for the output variable that drive the set of rule for the controller action and defuzzification, and the design should be supported by the figure wherever possible. And if the clothes are solid to the large degree, and the wash time will be more, and vice versa, and how we calculate this value, and that depend upon the defuzzification, and that time may be vary because it depend upon your values and it depend upon your assumptions, but you have to include all the step. That step 1, that you have to identify the input and output variable and decide the descriptor for the same, and after that you have to define the membership function for the each input and output value. After that you have to form the rule base, after that you have to evaluate the rule, and after that the defuzzification. And when you proceed this step again and again, first of all, that you have the input variable dirt and grease, that is in the percentage, that the output variable, that is the wash time, that is the minimum, that you have to calculate the wash time. Here is the descriptor for the input variable, that is the small dirt, medium dirt, and that one is the descriptor for the descriptor from the variables, and same thing we have to use. So that's all for the today.